Audio Jungle. Audio Jungle.
All right, so now we are going to discuss what is the speed of sound, right? The speed of sound. So basically, if you define what is the speed of sound, the speed of sound is nothing but it's a pressure disturbance, or you can say wave propagation. So on light mode, we can write the simple one-liner definition. Sound waves are infinitely small pressure disturbance. Pressure disturbance. Okay, and that pressure disturbance you will get. Suppose this is the source. Just take an example of it, so you may get it. This is suppose source. Okay, and here this is the source, and this source is what making noise here. Okay, so and somewhere here you are standing. So this suppose there is a here we have a cracker. Okay, now once it's burst, so what will happen, that sound wave will propagate. Okay, will propagate in this way. Yes or no, it will propagate. So this propagation of the wave in forward direction, okay, from the source to some distance, okay, where the observer is what is standing. If the strength of this source is what enough high, then it will reach to the observer and they can listen. Otherwise, if the strength of this source is what weak, then the observer will not be able to listen. So that time you can say, okay, I'm not able to hear your voice. Got my point? So basically this is what source, and this is nothing but wave propagation. What is this? This is nothing but wave propagation. Okay, so this wave propagation you will get because of some disturbance. So here this source, which is nothing but crackers, it will produce some disturbance. So what will happen, that wave propagations will start and it will move in forward direction. Okay, this is nothing but what, speed of sound. Okay, this is nothing but speed of sound. So generally this, here you may derive, okay, here you may derive this speed of sound. We have a different you know way to derive. In short, I will show you here. This is the one way. Actually, I'm considering this wave propagation, which is nothing but sound wave. Okay, there is moving in forward direction. So two things you can say. You can say this is the, because sound wave required a medium, so without medium it cannot propagate, so you may not able to hear the voice or that sound. Okay, so it's first thing, it's required medium. So I can say here the medium, we have a stagnant gas here. Okay, and for this stagnant gas, we can say that pressure is nothing but P, density is rho. Okay, and temperature is what, T. All right, now we can say here the sound wave, this is what sound wave you can say now, and it is moving in this direction with velocity a. Okay, so here this is nothing but what, sound wave. This is the very basic analysis of sound wave, so easily you can understand. Sound wave moving to the left with velocity a into stagnant gas. Okay, and obviously it is moving in this direction, so this side, because always propagation from high pressure high density, you can say high pressure to lower pressure, so you can say here that pressure will be what, somewhat high. So earlier this side it is supposed P, so this side is what, pressure is what, P. Similarly here it is density 0, so I am considering 0. Temperature T plus dP. Like here you can say cracker or any source is there, so because of it, you just simple example, you can say cracker we have this side, so because of it, like that temperature will be high. Okay, and that pressure will also be high because of the uh, extra energy has been added, so you can say like the pressure wave or sound wave is what propagating from the high pressure to lower pressure. So this is the one case you have taken where the sound wave moving in a fluid at rest condition, because fluid is what is stagnant means rest condition. This is the one example. Another you can say your sound wave here, it is what it is at rest condition. Okay, the another reference system you can take, and now you can say this is the motionless. Okay, you can say this is what motionless sound wave, you can say this is what motionless sound wave. Okay, but motionless sound wave in the sense what, you are saying that two reference system, one that medium is what is stagnant condition and your sound wave is what moving, okay, to the left with velocity a. Now here you are considering motionless sound wave, that sound wave you are saying it is now motionless. Okay, and this is the reference system attached to the sound wave. Okay, and here you just say, then obviously the velocity, it will be represented by a. Okay, this side pressure is nothing but p rho t, which is nothing but pressure, density and temperature. This is medium 1, and this side it is 2, and this side pressure will be what, p plus dp, rho plus d rho, and t plus dt, and obviously a plus sorry d da, sorry, make correction here, a plus da. This is the ahead of wave, and this is nothing but behind the wave. Okay, ahead and behind. So this is the another reference system, both conditions are same. Okay, this also you can understand by the piston cylinder arrangement, which is very common. Most of time you have seen this derivation by this arrangement. Now the how this sound wave can create simply, it's a simple example only. Suppose this is what piston. Okay, this piston can move in forward direction easily, it's a frictionless cylinder arrangement. And now here we have this sound wave. Okay, just say Here the pressure is what P, density is rho, temperature is what T, okay, and the speed is nothing but A ahead of wave, and here it is nothing but P plus dP, rho plus d rho, T plus dt, and A plus dA. All right, as same whatever the second condition I have taken, this is the another reference. The condition is what same here, that the medium is what is stagnant condition, okay, and wave is what moving. Now you can say here medium is not stagnant, and wave is what stagnant, or you can say motionless sound wave, okay, fine. What we will do here, it's very well known, like pressure, E is nothing but pressure, rho, density T, temperature of medium A, speed of sound wave. Now what you can say, this is the ahead to the wave and this is the behind. So you can say apply continuous equation in between 1 and 2 region. Region 1 is what ahead to the wave, and region 2 is what behind to the wave. What is the formula? Rho area into velocity. This area is what? Area is constant throughout the cylinder, okay. V is the velocity. So this velocity is what? Here it is nothing but A, which is nothing but speed of sound wave, and this rho AV is equal to what? Constant. This is the continuity equation. Rho AV is equal to constant. So very well known. Yes or no? Now you will apply. So what you will get? Check. Rho A, and velocity is nothing but small a, is equal to rho plus rho plus d rho. Area is what? Constant. Velocity A plus dA. So this area and area will cancel out. What you will have? Check. This value will cancel out. So you will have rho A is equal to what? Rho A, rho dA plus A d rho plus dA into d rho. So dA into d rho, it's a higher order. Meaning is dA you can say small, okay, and d rho is also very small. This is the small value. This is also very small. If you take the product, that will also very small. Yes or no? That product. So you can neglect this. It's a zero. And rest quantity also will cancel out. Rho A cancel out. What you will get? Check. So here you have the rho dA is equal to A d rho. Okay, now this is the equation 1, you can say. One very well known equation which is called Euler's equation. For compressible fluid, which is also called momentum equation for compressible fluid. What is that? Already in previous classes, if you check, I have derived. It is nothing but dP by rho plus V dV is equal to 0. Okay, if you integrate this, then you will get Bernoulli equation that you know very well, Euler's equation. No? This is called Euler's equation. In our case, dP by rho, what is the velocity? Instead of V, it is A. What instead of dV, it is dA is equal to 0. All right. So A dA is equal to minus dP by rho. Okay. Fine. Now connect that two equation. You have rho dA is equal to, I think, rho dA plus A d rho. If you take this side, then it will be minus here. Sorry, make the correction. Nah, this because this one cancel out, so it becomes 0. So rho dA plus A d rho is equal to 0. So rho dA is equal to minus A d rho. Hope you understood. So you have rho dA is equal to minus A d rho. Is it correct? Yeah. Check it. This is equation 1. Another equation is what? A d rho, ADA is equal to minus dP by rho. What we'll do now? What we can do? We can have this dA. We replace. This is equation 2. So you can say dA is equal to here only minus dP by rho into A. Yes or no? From here you can write. Now it's rho, instead of dA it will be minus dP by rho A minus A d rho. Okay, check the calculation. Rho cancel out. What you may have? Minus dP by rho. Sorry, rho cancel out. This and this rho will cancel out. So what you may have? Sorry, it's A is equal to minus A d rho. Then again minus minus cancel out. What you may have? A square is equal to dP by d rho. Check it. Okay. So what you got is speed of sound speed of sound A is equal to, you got dp by d rho. It's a very generic equation, okay, very generic equation. Now this is speed of sound we need to calculate for different cases, okay. We can say speed of point 1, I can write speed of sound speed of sound for isothermal process. Isothermal process means constant temperature. T is equal to constant. We have equation PV is equal to RT. R is constant. If P is also constant, it becomes constant. Means PV is equal to constant. Yes or no? So it will be what? P plus dV and V plus dP is equal to 0. Alright. P plus dV, V plus dP is equal to 0. We know the specific volume small v is nothing but volume by mass. Volume means total volume divided by mass, or mass by total volume. This is nothing but 1 by rho. So specific volume is nothing but 1 by rho, which is nothing but density. So here we can say rho v is equal to constant. We can differentiate this rho dv plus v d rho is equal to 0. Then what will be the value of dv by v? It will be minus d rho by rho. I think check it. Fine. So now as we have this equation, check what is the dv by v here. What is the dv by v? It is minus dv by v minus dp by t. Yes or no? So d by dv also is nothing but minus d rho by rho. Hence we got dv by v is equal to, check once again, minus dp by p. So also d rho by rho means if somewhere dp by p is there, then you can write d rho by rho, or if dp by d rho is there, then what you can write? dt by d rho is nothing but p by rho. Okay. One more thing, you know, bulk modulus. In my previous class, I had derived the derivation. It was denoted by B or K. In few books, it is denoted by K or capital B. Okay, your choice what you want to write. So I must write K. What is the bulk modulus? Already it is derived, okay, in my previous lectures. Change in pressure divided by volumetric strain with minus sign. So this is nothing but change in pressure is dP minus sign. Why it is minus? Because once you apply the pressure, then volume will decrease, hence you will have a negative sign. Volumetric strain means change in volume by original volume. Okay. So what is the K you got here? What is the K you got here? Check. It is this derivation already I have done. Okay, I have derived this bulk modulus. I am not writing directly. It is already derived. Here I am writing directly. Okay, check my previous lecture. dV by B or minus dP by, what is the dV by V? Check. See what is the dV by V? Check, it is nothing but minus d rho by rho. Just now here it is derived. No? See this value dV by V is nothing but minus d rho by rho. So this is minus d rho by rho, or you can say rho dP by d, or dP by d rho will be k rho. Okay, final what you are going to write. Check what dP by you have written here. dP by, here you got dP by d rho is equal to P by rho. Na? dP by d rho is equal to P by rho you got. P by rho. And here dP by d rho is equal to also you got K by rho. This is very important result. Okay. One more thing you can say for isothermal flow. Check what is the dP by d rho you have calculated here. It is P by rho. Also you have calculated in terms of bulk modulus K by rho. Can you say for isothermal bulk modulus is nothing but directly P? Yes, this result is very important. Okay. Pressure of, if somebody will ask to you what is the bulk modulus for isothermal process, you have to say it is the pressure of fluid. Whatever the pressure of fluid will give the value of bulk modulus, means Kt is equal to pressure P. Okay. Now what is the speed of sound? What is the speed of sound in isothermal process? Speed of sound in isothermal process, it is nothing but, check what you have derived. You have derived A is equal to dP by d rho. Then what you got dP by d rho? You got here P by rho. P by rho. Okay, one more thing. For ideal gas, P V is equal to RT, or you can say V is nothing but by rho, because what is the V? V is the specific volume. Just now here you have written, see, specific volume is 1 by rho. Check. You can replace this P by rho. So P by rho also you can write RT. Or what is the P by rho? Here you have derived, it is K by rho or K by rho. These are the formula of speed of sound for isothermal process. Okay. These are the formula of speed of sound. Where what is the K? Bulk modulus of fluid or medium where you are calculating speed of sound. Okay. All right. Now, similarly, this also you can write in speed of sound for adiabatic process. So let me write here. So here, this is second point. The speed of sound in isentropic process or isentropic flow. Okay, what do you mean by isentropic? Isentropic means very simple. It's a reversible adiabatic. Reversible means frictionless. Adiabatic means no heat transfer. No heat transfer. Okay. Anyway, so for isentropic process or isentropic flow, what is the relation? Relation is very well known relation PV to power gamma is equal to constant. This is what? This is the relation for adiabatic. Okay, adiabatic. So it is also called isentropic. Now you have PV to power gamma is equal to constant. You differentiate it P into gamma. Okay, V gamma minus 1 dV plus V to power gamma into 0. What you can write P into gamma V to power gamma divided by V into dV plus V to power gamma into dP is equal to 0. Check. Next step, what we will have? P into gamma dV by V plus dP is equal to 0. V to power gamma both will be cancelled out because right side value is what 0. So take common and make it 0. So what you will have? You will have P to power P into gamma is equal to dP by V. This is also minus dP. What is dV by V? Check. Previously you have done that. dV by V somewhere. See, dV by V is nothing but minus d rho by rho. Minus d rho by rho. dP by d rho into rho. What is this? Check. This is what? Can you say this is the bulk modulus somewhere? Bulk modulus. Check here. Yes or no? So this is nothing but bulk modulus. Okay. So you got K is equal to P to power gamma. This is isentropic, so I am writing Ks. So very special value. This is also very important for one day exam. Bulk modulus for isentropic flow. What is that? It's a Ks is equal to gamma p or p gamma. It's your choice. Okay. One more very important point. Let me write here. Ratio of bulk modulus for isothermal and isentropic flow. What is that? Check again. Write isentropic divided by isothermal. What is the isentropic? You got gamma p. What is the isothermal? Previous check. Isothermal is Kt is equal to p. What you will have? Gamma. Okay. If I say bulk ratio of bulk modulus for isothermal and isentropic flow, oh, okay. I can mention one more thing, so it will be more clear. Isentropic air flow. So air flow I am writing. So this gamma will be what for air. What is the gamma value for air? It is 1.4. 1.4 is greater than 1. Hence, for air bulk modulus is always greater than, I mean isentropic bulk modulus always greater than isothermal bulk modulus for air. This is also very important, okay, for one day exam. Star. Okay. Fine. Then what is the speed of sound? In isentropic flow. Check. A is equal to dp by d rho. This is the formula. Now check what is the dp by d rho. Speed of sound. Dp by d rho. Check here. What is the dp by d rho? By any formula you can check. See dp by d rho here you can calculate. What will be dp by d rho? Check it. dp by d rho will be gamma p by rho. Yes or no? It will be gamma p by rho. I can write here. dp by d rho is nothing but gamma p by rho. Okay. What is the gamma p? It's a bulk modulus for isentropic divided by rho. What is the gamma as it is? P by rho is nothing but what? RT. Huh? What is the P? P is equal to rho RT. So what is P by rho? RT. So here A is nothing but again I will write dp by d rho. This is the final. Then gamma p by rho. What is gamma? P by rho. P by rho is nothing but RT. So it is gamma RT. Again gamma p is nothing but Ks. Ks means bulk modulus for isentropic flow divided by rho. This is the formula for speed of sound in isentropic process. Okay, one more. You can write the speed of sound for incompressible fluid or ideal fluid. Ideal means what? What do you mean by ideal fluid? Steady, incompressible, irrotational. Okay. So here I am considering incompressible. So what is the mean of incompressible? Rho constant. What will be d rho? 0. Then what will be the speed of sound? A is equal to dp by d rho. That means infinite. This is also very important. For incompressible fluid or ideal fluid, the speed of sound will be infinite. For the ideal fluid, what is the bulk modulus? For ideal fluid, what is the bulk modulus? Bulk modulus will be infinite. Again, if you check the formula speed of sound in terms of k, anywhere it is k by rho. Here also the speed of sound will be 0, infinite, not 0, infinite. You know, right? In fluid mechanics, you might have seen that ideal fluid like water and all. So ideal fluid bulk modulus is what? Infinite means that what is the bulk modulus? Bulk modulus is the internal property of the fluid, which is nothing but resistance. Resistance to what? Resistance to compression. If bulk modulus is infinite, it means that fluid is what? Not allow compression. It is resisting with very huge amount of the forces, which is nothing but infinite. So it will not allow the compression, so there will not be density change and all. Alright guys, so this was all discussion what here I have shown you, and I have described the things. So it was related to the speed of sound. Alright, thank you.